Hello everyone, Andrew is here. Let's wait some time. Maybe someone else connected. And so today I change camera and it seems like image a little bit nicer. And also one guy said that sound is a little bit quiet, so I try to increase sound. So please type in the chat. Do you hear me and see me? And so today's agenda is video description, and I believe that all read it. And so let's start. We will start at primary scheme. This is substation A, this is substation B. These two substations are big, so this A has something around 10 lines, 110 kilovolts, also 330 kilovolt lines. This one the same, but they are connected by, in this particular case, only by two 110 kilovolt lines, parallel lines. These lines, something around 30 kilometers long, and they have two tap substations. Tap substations don't have any line protection, but they have earthing switches and automatic disconnectors. So I have some trouble with it. Sorry. I'll refresh it. Okay. It happens. Sorry, guys. While it's refreshing, I return to my speech. So usually this two substation has other connections through the 330 grid, but after attacks, it was divided by our dispatching department, and the primary scheme of the 110 kilovolt switch yard on both substations is a double bus with a transfer bus, and on substation A, and on substation A, this circuit breaker is opened. and on this bus bar is only load, and grid is connected to the another bar. So this part of substation A receives power through these two parallel lines from substation B. So if talk about protection philosophy, on substation A there are L030. This is ID from our Ukrainian manufacturer and well-known 7SA 611. On both sides, designers made connection for mutual coupling, but our settings engineer don't use it. From the on the substation B side, protections are the same, except that there are BC units based on REC 670 from ABB. LO30 is the main function is phase-differential protection, and it has high-frequency communication channels. In this particular case, a communication channel on first line was damaged, and only on second line a communication channel was in work. I wrote here frequencies. So on the first line is 230 kilohertz, and on second line 156 kilohertz. So I want to show you this. This is like it looks, and this is CTs, VTs, and here is shown transmitter receiver. So this is not modern design. It have implemented, I believe, in 2010, and it has old transmitter receivers. Transmitter receivers also made in Ukraine, and one of the manufacturers also located in Odessa. This Odessa is the city where I'm located, and this transmitter receivers looks like that. This is old one. They now produced microprocessor based transmitter receivers. So it looks like that. And if to talk, add few words about this Ukrainian manufacturer, it starts its history in Soviet Union, and I believe that you know SS-18 and SS-19 ballistic rockets that had called Satan, and mostly all big space programs was in Soviet space was built by because this manufacturer produced very powerful rockets. If to talk about phase differential protection, I believe in Western world the most famous ID is L60 from GE, but they call it line phase comparison system. In post-Soviet area, we don't use these terms. We mostly say phase differential protection. So let's review some functions that are enabled in devices. So LO30 has phase differential protection, two zones of distance protections, two stages of earth fault protection, overcurrent, SOTF function, breaker failure protection, but also auto reclosing function. For SOTF functions, usually used second zone for distance protection and second stage of earth fault protection. If talk about Siemens device, there is 4 zones of distance protections, 4 stages of earth fault protection, and pretty much the same like this guy, but also it has emergency overcurrent, time overcurrent protection. It enabled in case of loss of VT. And I want to add about primary scheme a little bit. Usually with such scheme, we VT are connected only to bus bars to make scheme a little bit cheaper. From that side, it's pretty much the same, except that RAC 670 has breaker failure protection and auto reclosing function. Let's talk a bit about communication, high frequency communication channel briefly. Usually for this type of communication used wires of the line, and to filter high frequency signals from usual grid frequency filters used. So you can see on this picture this point connected to the switch yard, this connected to the line. This is like low pass filter. And here band pass filter. So in this picture, schematic and picture, you can see that how it looks like. So this band pass filter is connected to the transmitter receiver. This low pass filter simplified. Usually there are a lot of elements, not only inductance. Let's talk about how phase differential protection works. I place this here few pictures from different manuals. From the left side, you can see L60 from GE, L30 from picture related to L30 from the right side, but this is a picture from old book from 1977 about electromechanical phase differential protection. So the main it's them have a lot of in common, and from this part you can show you can see fault that are located on the protected object, external fault, but on electromechanical picture that shows how electromechanical works, it will be different. So here you can see the external fault, but here fault on protected object. So you can see that main difference is that it compares the phases of the signals, and in case of the fault on a protected object, there will be pauses and current on the output of the transmitter receiver. So if look at but on external fault in a high frequency communication channel, there will be high frequency signal without interruptions. And if you look at picture from L60, there is also signal without pauses. And here also for external fault, we can see that in this case, in high frequency communication channel, there will be high frequency signal without any pauses. So usually for this phase comparison used not phase currents or line currents, usually used mixed mixed signal for L60 is this is a combination from negative sequence current and positive sequence current. So equations look like this. From a negative sequence current is minus coefficient positive sequence current. But for L30 and for our old electromechanical protections, usually used these equations used. So this pictures also shows when protection initiates trip. So if pause is smaller than some angle, because in time we have pause in time domain, but this time can be equivalent to some degrees, electrical degrees. And if the pause is smaller than a certain amount that usually set in protection, so in that case protection will be blocked. And this is shown for L60. This is for old electromechanicals, but the same is for L30. So if to look at tripping logic, it looks like complicated, and it's really more simple, and I want to describe how protection work on old electromechanical scheme. It look a little bit complicated, but I believe easier to understand how it works. So this part of the scheme is distance relays. These two relays is related to phase current, and these two relays here you can receive combination of zero sequence current and negative sequence current. And here you received this mixed signal that goes to transmitter receiver, and this signal is manipulating by this transmitter receiver. So and these two relays, one is responsible for the start of protection and other for trip. So to receive trip, you need to get these pauses and receive assertion of any of the trip relays, and it will the protection produced trip. So this is phase comparison element, but I believe that's enough. But logic of protection is very simple. So in this particular case, settings from the L30 little bit more complicated than for electromechanical protection. So we have start and trip by positive sequence, negative sequence, zero sequence, but also from distance relays, relay that act only for trip. And this coefficient A means that in this signal K will be 8, and this is degrees, so the block protection will be blocked if the pauses will be more than 2 times 55 degrees. So it will be blocked in 104 degrees. So let's return to our primary scheme. So if you have any question, please type in the chat. I find time to answer questions. So initially we received information that two lines were tripped by protection, and also dispatching department said that from this first line was tripped from also substation A, but R was successful, and it was unsuccessful from the substation B side. And the first thought was that this protection, some of the protection was so sorry. I had a mistake. Second line tripped with successful R, but first line tripped only from substation B side. So on both substations implemented digital fault recorders, and from cybersecurity reasons we have more easy access to the records from these recorders, and we will start with them. So let's start from the substation B part. On the top we see voltages, and here we can see currents. The first strange thing that on first line current increased a lot in phase B, but on second line current increased on phase A. Also, you can here you can see frequency, high frequency signal, and you can see the pulses. For external fault, the signal will look like that. So and if to look to voltages, we can see that voltages in phase A and B decreased. So let's try to add zero sequence parameters to see was there any zero sequence. So I'll calculate zero sequence current for first line, and for second line. We can see that we have this zero sequence current, but it's like in opposite direction in each line. So let's add zero sequence voltage. And it was surprise, but we don't have zero sequence voltage. So that means that we have like short circuit between two lines, and without without ground. So on the first line, it looks like it was phase B, and on the second line, phase A. So let's return to our picture. And something like that. The one moment about digital fault recorders. It's also from our Ukrainian manufacturer, and it has their own software, but it has issue that when it transfers file to contrate format, it inverts digital signals. So when it zeros, so that means that the signal was asserted. And if to look to digital channels, so we see that on line one we have trip signal from LO30. Then we have trip from trip signal from 7SA on second line, and also 7SA from third line. So this is this signal have had some delay, and here on the bottom we have assertion of the R. And R was pretty much the same on both lines. So first was on line one, and a little bit later on the second line. So let's check is it correct, and look what we can see from the substation A side. This is first bus bar, this, and this is voltages from the second bus bar, and on the bottom currents from the second line, and on the top the currents on the first line. My camera is switched off, but I believe it will return. One moment. Okay, I'm here. Sorry, I try to find some solution to not spend a lot of money, and I decided to try this camera and look how it will be, the software will behave during this thing. So let's look on first line. Here we can see that currents, voltages started on the second bus bar, but on the line 2 we don't see anything. So to make analysis a little bit easier, I'll add these two files to one window, and we will see what happened from that perspective. So they are not synchronized good, and I need to synchronize these files by hand. So what we can see on the top, my reminders. On the top we have a file from substation A, on the bottom from substation B. So if to talk about why we don't see the currents on second line from the substation A side. If we look to digital channels, here was inserted R signal from LO30. So that means that this line also tripped by, but R was a little bit later than on first line, and that's why R was successful. But we don't understand. At this moment, it's not clear why we can see these currents and what's true. So let's look at this is substation A. Let's analyze what's tripped on substation B side, because it's easier a little bit. So we have from substation B side records from Siemens relay, and also from LO30 from Hartron, and let's start from that. So if we look at high frequency communication signal, we can understand that this line mostly was stripped by differential protection. This is substation B only. Sorry. Let's add my reminder. On first line we don't have high frequency communication channel between devices, and only backup protection. Video file. The main one thing I need to at current we have ratio 2200 to 1. So, here, okay. switching to primary. Something. Now I'm linking analog channels to impedance calculator. Voltages. So we talk about first line. As we can see, the the yellow one is impedance loop in phase AB loop. So it was in first zone. Let's add Hartron device. We don't need to see all the zones, so and let's insert settings for LO30. Characteristic is set by 4 points on impedance plane. Oh, sorry, I'm inserting it on the ground in the ground section, but I want to remind you and me that on these devices only multi-phase distance is enabled. So we can see that it also impedance also in the first zone. So let's if to talk about second line, we also can check this that on second line also can work a distance protection. And what interesting fact and what I found interesting, that our settings engineers put some delay on Siemens devices, about 50 milliseconds, but on Hartron device there is no delay. So first initiate trip signal LO30 protection. Because settings are the same from each line, I can show that so at this point we see what happened on first line. Now let's change to the second line. So impedance is a little bit differ, but also impedance in AB loop, also in first zone. So this line can be tripped, was tripped by 3 protection functions. In Siemens, there was a first zone of the distance protection, also first zone of the distance protection in LO30, and also phase differential protection. To check this about phase differential protection, we usually it's enough to just see this high frequency channel, but we can sorry, I closed the window, but never mind. We talk about substation B. And to check if the phase differential protection work, we can see that it started because we can see a high frequency signal. If the transmitter receiver was not started, there is no any signal recorded. And we need to check these parameters. So was it enough reached these parameters to trip condition? So we need to calculate positive sequence, negative sequence, and zero sequence current to check it. So this is related to second line. Let's calculate it. So first I'll start with positive sequence. Positive sequence is 2,800, almost 800 amperes. So if we return to settings, only already only positive current was enough to initiate trip. But we can continue and calculate other parameters. So let's check negative sequence current. More than 1 kiloamperes, and it also was enough to initiate trip. Let's finally check zero sequence current. I believe I made mistake by calculating positive sequence current, because let's check it. Sorry, yes. Sorry, guys, I made a mistake. First time I not calculate positive sequence current. I calculate zero sequence current. But if we look to the settings, it's much smaller than that value. And let's calculate positive sequence current. It's 1,490 amperes, but it was also enough to trip because for positive sequence current we have this value. So I believe we finished from the B side, substation B side. So to make some resume, so like second line tripped by a phase differential protection, distance protection in 7SA611, and by first zone of distance protection of LO30. On the first line, also distance protection work, also first zones of distance protection in Siemens and Hartron devices. So let's check what happened from the substation A side. From substation A, we don't have any records. So first, let's check distance phase differential protection, because we can see that there is pulses, but also we can see that current from the substation B side are much smaller. So first, let's calculate can phase differential protection work. And we process will be pretty much the same. So first we will calculate positive sequence current, negative sequence current, and also zero sequence current. Let's start with positive sequence current. So it's a little bit more than 100 amperes. So let's return to our settings. It was not enough to initiate not only trip but also start. Let's return and calculate negative sequence current. A little bit more, and almost 165 amperes. So let's check our settings. Yes, so I believe that this channel was initiate starting of the protection and also trip. So the current was big enough to initiate start and trip. So finally, let's check the zero sequence current. Something around 1,500 amperes. So also these values lead to start and initiating start and trip signals. So let's check distance protection. So from substation A side, at least this circuit breaker can be tripped, was tripped by phase differential protection from LO30. So let's check distance protection. Let's return here. So I need to manually insert settings. Okay. Phase loop. This one. Let's start with Siemens. X. first zone and L30. Views, and finally a minus. Impedance calculator, and we need to link it. So here our voltages, and let's start with second line, because we found that second line was stripped by phase differential protection, and let's check was it able distance protection to trip. So as we can see, no. So why that? So, it's because here we have only load, not any source. So distance protection from substation A side sees only like impedances of the load. So for line 1 we have the same settings, so we just need to relink to calculator currents. Phase A, phase B, phase C. We see pretty much the same picture. So for distance protection from the substation A side, this fault seemed like external fault, because that to substation A was connected only load. So what sequence of events? How I can understand? Let's close all circuit breakers. When fault starts from substation B side, circuit breakers was stripped, so we had this type of fault between phase B from line A, first line, and phase A on second line. So from substation B side, circuit breakers were tripped on second line by phase differential protection, but also by distance protections in Siemens and Hartron devices. So let's but also currents was big enough to initiate trip on that side of the second line. So from this side, circuit breaker was opened by the phase differential protection. But in this case, when three circuit breakers was opened, we lose voltage on the bus bar. So there is no need to any protection, and there is no any parameters for protection to trip this circuit breaker. Then we can see that's why we can see current that goes through the first line when there was R from substation B part, because it was no any this circuit breaker was not tripped. So when in period time of R, we can see this condition. So this circuit breakers was closed by R at the same time, and this circuit breaker was opened. So that's why we only see currents on line A and don't see any currents on line B. After I have we can also analyze behavioral protection in R cycle, but it was almost the same parameters, so it also will be tripped by first zones of distance protection, maybe by SOTF functions, but for me this is like clear, and I believe we don't need to dive in that. So after R, these circuit breakers also were opened. And after that, on the second line, circuit breaker was closed by R. And we received the picture that was information that we initially received. So that's all I want to say. Let's look in the chat if there were any questions. Okay, I don't see any. So if you have some question, please type. I'd be happy to answer. Okay, I don't see any questions. So next time I want to talk about extra high voltage grid, and I want to my camera just okay. I return. And I want to take a look on extra high voltage grid, and I want to make case study on unsuccessful IR on 750 kilovolt transmission line. So that's all. Thank you for watching. Peace for everyone.